Congratulations on the purchase of the Bruker Elemental S1 Titan Analyzer. This video was developed to help you better understand the operation of the unit and its accessories. For more information, consult your user's guide. The unit comes in a watertight Pelican case. Always return the analyzer to this case when it's not in use. In the case, you will find the following items: the analyzer with the attached wrist strap, 2 lithium-ion batteries, a lithium-ion battery charger assembly. The assembly is made up of 3 parts. 1. The charger. 2. The power supply. And 3. The AC mains cable. The background plate should be used when analyzing small samples, thus eliminating interference from other materials behind or around the sample. The plate also absorbs X-rays, providing additional safety from X-rays that might otherwise penetrate the desk, table, or other surface. A Phillips screwdriver for removing the nose piece standoff. The standoff must be removed to replace the protective window. A USB flash drive, which is used to transfer data from the analyzer to a PC. A kit of 5 replacement windows for the analyzer. These protect the analyzer from dirt and contamination. Additional windows can be ordered from Bruker. A CD containing the calibration data and the files for your instrument. A 2205 check sample, which is used to confirm the calibration of the analyzer. A calibration certificate for the analyzer. A QC datasheet for the 2205 check sample provided. A quick start guide which provides instructions for the startup of the analyzer. A user guide which gives you instructions on the operation of the analyzer and software. A radiation profile of the specific instrument that you've received. A periodic table of the elements and X-ray energies. And a user guide for the batteries in the battery charger. 2 lithium-ion batteries are supplied with the analyzer. Each fully charged battery can operate the analyzer from 6 to 8 hours depending on how often the X-rays are generated. At a 50% duty cycle, the average battery runtime is 7.5 hours. Pressing the button on the side of the battery will illuminate a fuel gauge that will indicate the relative charge level of the battery. 4 illuminated LEDs indicate a fully charged battery. To operate the battery charger, plug the DC connector from the power supply into the back of the charger. Connect the power supply to the mains AC supply using the cable provided. Insert the battery into the charger. While the battery is charging, the charger indicator LED will flash green. When the battery is fully charged, the charger indicator LED will be a solid green. The control panel of the analyzer is made up of 2 buttons, plus an infrared or IR proximity sensor LED. The left button is the power switch. To turn on the unit, press the power switch. The instrument will take several moments to initialize. To turn the instrument off, press the power switch again. The right button is for analyzers configured with an optional auxiliary trigger. The middle LED is for the IR proximity sensor. This LED lights up when an object is within range of the examination window. X-rays cannot be generated if the sensor is not detecting an object. The operator trigger is used to start and stop measurements. Note that all safety features must be met in order for the trigger to initiate the generation of X-rays. The rear panel port area is located underneath the control panel. The USB port is used for USB connections to a computer. The connector is a USB Mini B. Thus, the appropriate cable for connecting to the computer is a USB-A to USB Mini B cable. The remote port is a general-purpose I/O port, which is used for connection to optional accessories. The flash drive port is used for connecting a USB flash drive for the purpose of storing and transferring data. The 9-volt DC port is for the optional AC adapter. On the front of the analyzer, the top opening is the measurement window, and the bottom opening is the IR proximity sensor. There are 3 X-ray warning lamps, one on either side of the instrument, and one just under the control panel. When the trigger is pulled and the infrared sensor is engaged, the red lamps will illuminate, indicating the generation of X-rays. The lamp incorporates redundant LED elements for increased reliability. If any of the red LED elements fails, X-rays cannot be generated. To prepare the instrument for normal operation, it's necessary to install a fully charged battery. To start the analyzer, simply push the power switch on the control panel. This will start the initialization process. When the initialization is complete, you'll see the login screen. Tap the login button and enter the password 12345 and tap OK. When the radiation warning window appears, pull the trigger to acknowledge the warning. The main menu appears and indicates Ready to Test at the top of the screen. At this time, you're ready to make a measurement. When the S1 Titan is turned on, all the settings will be exactly the same as when it was turned off. When making a measurement with the S1 Titan, the surface sample should be flat, smooth, and clean. If there is paint or corrosion on the surface of the sample, this will cause erroneous readings. If there is a curved surface or other sample irregularities, the accuracy of the readings will be lower than a flat sample, which completely covers the window. In order to make a measurement, simply place the analyzer on the sample, pull the trigger, and hold it until the measurement is complete, then release the trigger. If light elements like silicon and aluminum are being measured, the condition of the surface finish is even more important. In this case, heavy cutting marks and coarse scratches will interfere with the measurement. If necessary, a grinder with a 60-grit abrasive can be used to remove unwanted surface finish and provide a suitable surface for measurement. The IR sensor in front of the analyzer is an important part of the safety circuit. This sensor detects reflected infrared radiation and confirms that a sample is in place in front of the analyzer. If the sample does not cover the IR sensor, the safety circuit will not allow X-rays to be generated. The red light on the control panel will not illuminate, and no measures can be made. Once the IR sensor is satisfied and the trigger is activated, the red light on the control panel will illuminate, and the measurement will begin. For certain dark-colored materials which will not reflect the IR radiation, or irregular shaped materials that will not cover the IR sensor, it may be necessary to temporarily defeat the IR sensor in order to take an assay. In addition to the IR sample sensor, there is a backscatter shutoff. This detects when the count rate falls below the preset count rate. If the sample is removed from the analyzer before the measurement is completed, this shutoff will turn off the X-rays and provide an indication of the reason for the termination of the measurement. Once the sample is prepared and the interlocks are satisfied, the final factor in starting the measurement is the state of the analyzer software. There are two states where the analyzer can start an analysis: at the conclusion of the previous measurement, or at the Ready to Test screen. If all of the conditions are met, then pulling the trigger on the instrument will start the measurement. This will be indicated by the red X-ray lights coming on and the data appearing on the screen. If for any reason the red light goes off, the measurement will stop and no additional data will be taken. Note that one cause of premature termination of the measurement is that the battery has become discharged. At this point, the on-screen warning will indicate the battery charge is low. If the measurement ends prematurely, one of the first actions to take would be to replace the handle battery with a fully charged one. When the trigger is pulled, X-rays are activated, and this should quickly result in the display of a set of data on the screen. The main menu allows the selection of Application, Method, Settings, and Display Settings. See the user guide for description of these various controls. If the display setting is the grade library, the data display will include the grade identification on the first line of the display. If there are several grades which are very similar, there may be up to 3 grades identified on this line. The second line of the display includes the measurement ID number, This number will be saved with the data and in the results file. This ID number becomes the internal identification of the sample. The match quality number. This number indicates how closely the first grade matches the current sample. The best possible match is 10. Any number better than 8 indicates a good agreement between the grade definition and the sample being analyzed. The system's date and time. The third line of the display indicates the assay time in seconds. In the bottom section of the screen is the analysis of the sample. The first column is the identification of the element. The third column is the assay of the sample. The second and fourth columns indicate the expected range of the element in the grade definition displayed. The last column displays 2 times the standard deviation of the measurement. When an element is defined within a grade, the analyzed value for that element is compared with the grade limits. When the assay is within the grade limits, the assay will be highlighted green. If the assay is outside the grade limits but within the range defined by adding 2 times the standard deviation to the grade definition, the assay is highlighted in yellow. If the assay is outside of the range, even when considering the standard deviation, it's highlighted in red. If the display settings is none, the display will be similar to the above, but without the grade ID on the first line or the grade limits in the second and fourth columns. In addition, no color codes will be applied to the assay. For other display settings, see the user guide. At the end of each measurement, there is a slight delay after releasing the instrument trigger and the end of the measurement. This allows the assay to be calculated and the measurement conditions to be reset for the beginning of the next measurement if necessary. It's essential to wait for the completion of the measurement before activating the trigger for the next measurement. The best way to be certain that the measurement is complete is to look at the bottom of the screen. When the small spectra at the bottom of the screen disappears, the analyzer is ready to perform the next assay. If the instrument is unused for about 10 minutes, the password screen will appear. To restart the analyzer, simply input the instrument password. The analyzer will return to exactly the same state that it was in when the timeout occurred. If the instrument is unused for about 15 minutes, the screen will shut off and enters a standby mode to save power. Tap the screen to reactivate the display and then enter the password. This timeout is part of the safety precaution. If the analyzer is left sitting, an untrained person cannot operate the instrument. To shut down the instrument when you've completed your work, simply press the power button. The easiest way to transfer the data from the analyzer to a computer is to store the data directly on the USB flash drive supplied with the analyzer. Remove the USB flash drive from the analyzer and insert it into an unused USB port on your computer. You can now copy the results.csv file from the USB drive to anywhere on your computer. The file can be opened using Microsoft Excel. In order to store your future data directly onto the USB flash drive, simply insert the USB flash drive into the flash drive slot on the back of the analyzer. Once the flash drive is installed into the instrument, the software automatically stores all data on the flash drive. If no flash drive is installed, the data will be stored in the processor memory and can be transferred to the USB flash drive using the system software. See the user guide for instructions.